All right, here are the work solutions for the Check for Understanding that I posted to Teams in preparation for your 7-1 to 7-3 quiz. Is the following positive, negative, or zero? So two things we have to consider here. Quadrant and which trig function we're looking at. So 7 pi over 6, when we're working in radians, it's all about the relationship between the numerator and denominator. So my top number is my bottom number plus 1. Because of that relationship, that puts me in quadrant 3. Okay, so 7 pi over 6 is a third quadrant angle. If I go back to what do my ordered pairs look like in each quadrant, in the third quadrant, both my x and my y are negative. I know that my x-coordinate represents my cosine value. So in the third quadrant, the cosine of any angle measure is always negative. In what quadrant is the following angle? Okay, so I don't care about sine or cosine here. I just want to know the quadrant. So remember, when we rotate, we always start from the positive x-axis. I like to think of these angle measures first as positives. So if I just look at 2 pi over 3, 2 pi over 3, again, relationship, my top number is my bottom number minus 1. So 2 pi over 3 is a 2-quadrant rotation. Well, because my angle measure is negative, I have to rotate in the clockwise direction from start, not the counterclockwise direction. So that means from start, I'm rotating clockwise and I stop in the second quadrant of rotation, not the second quadrant when I'm looking at here's my first, here's my second, my third, and my fourth. It's a 2-quadrant rotation in the clockwise direction. So where does that land me? That lands me in quadrant 3. In what quadrant is this angle measure? Okay, so here I am again. In radians, it's all about the relationship between the top number and the bottom number. My top number is twice my bottom number. It's 1 less than twice my bottom number. So when I did this video, I tried hard to get you to realize 1 pi, 2 pi, 1/2 pi, and then 3/2 pi. So 7 pi over 4 is really close to 2 pi, but we're not yet there. So as I think about where my angle is relative to the x-axis, 7 pi over 4 has this relationship, and that's what puts it in the fourth quadrant. Okay, I'm going to say it. I'm going to put it with the directions for the quiz. The expectation is that you do not use a calculator on this quiz. So again, you should not be using a calculator on this quiz. Okay, 91 degrees and 100 degrees. Quadrant 2 angles, so I'm just focusing here. So quadrant 2, up at 90 degrees, I'm at the ordered pair 0, 1. Over at 180 degrees, I'm at the ordered pair -1, 0. I'm comparing my cosine. My cosine are my x values. So in the second quadrant, my cosine value starts at 0 when I'm up at 90 degrees, and then it decreases in value to -1. So in quadrant 2, so in Q2, my cosine decreases in value. Oh, sorry guys. So let's think. Here's 91 degrees, and that's even off because it's going to be super duper close to 90, and we would put 100 here. So if I'm getting smaller in value as I rotate, well then 91 degrees, the cosine of 91 degrees has to be bigger than the cosine of 100 degrees. Okay, so now I have a point on a circle, and the terminal ray ends at 1, -2. And 6 and 7, it's the same picture, sine and cosine. Okay, my sine function is my y value over the radius. Okay, well, I know half of that. I know my y coordinate is -2. How do I find my radius? It comes back to our relationship for the equation of a circle. X squared plus y squared equals r squared. Okay? Here's my x coordinate, and my y coordinate is -2. X squared plus y squared equals r squared. So I have 1 plus 4 equals r squared. I don't know what's going on with my Bluetooth. 5 is equal to r squared. Now technically when we take the square root, we get a positive or a negative, but this has been in the notes before. Your radius has to be positive. So I'm just going to use the square root of 5 for r. All right, so sine is y over r. We just found our radius to be the square root of 5. So my radius is the square root of 5. I'm okay with you leaving it like that, but I put the answer in as a rationalized answer. We've been doing rationalizing, so we might as well continue. So I'm going to multiply by the square root of 5 on the top and bottom. So I get my sine of theta is equal to negative 2 root 5. I really don't know what's going on here. Negative 2 root 5 all over 5. And that makes sense because in the fourth quadrant, my sine function's negative. All right, so now for cosine, I'm not going to change the screen. We'll just use the same picture. Now my cosine of theta is my x-coordinate over my radius. All right, so what's my x-coordinate? My x-coordinate is just positive 1. We found our radius to be square root of 5. When I rationalize this, multiplying by square root of 5 in the top and bottom, I get the cosine of theta is equal to positive root 5 over 5. And that makes sense also, again, because I'm in quadrant 4. If I go back to... in the fourth quadrant, my x-coordinate is positive while my y-coordinate is negative. X-coordinate represents my cosine. So whenever I'm in the fourth quadrant, my cosine better be positive, and my sine is always going to be negative. So the fact that this terminal ray, the angle ends, it terminates in quadrant 4, cosine is positive and sine is negative. Oh, did I skip one? Okay, so I just did it once to find sine and cosine. Okay, so now given that the sine of theta is equal to 2/3, find all values of the cosine of theta. Okay, so it's a lot like the previous problem. We're using the equation of a circle. X squared plus y squared equals r squared. And I know that sine of theta gives me y over r. So I'm going to plug those values in, and that'll enable me to find x. Okay, so x squared, that's what I'm looking for. Y is equal to 2. R is equal to 3. Okay, so I have x squared plus 4 equals 9.
No, Maggie, unlock the door right now.
All right, so I get x squared is equal to 5. Now here, when I take the square root, I do include both values. So x is going to be plus or minus the square root of 5. Why is that important? It's all about the quadrants. So when I go back to my given information, so, and I am going to use these letters. I did this in the video where I have A, S, T, C, where those letters tell me which trig functions are positive in the given quadrants. So sine is positive in quadrant 1 and quadrant 2. So in if I'm given the sine of theta is equal to 2/3, theta can be a first or a second quadrant angle, and that's very important. In the first quadrant, cosine is also positive because everything's positive in the first quadrant. So my given information, again, sine is positive. If the sine ratio is positive, then theta can be a first quadrant angle or a second quadrant angle. If theta is a first quadrant angle, then cosine is also going to be positive because all my trig functions are positive in the first quadrant. If theta is a second quadrant angle, though, The sine ratio is positive, but the cosine ratio has to be negative. So in my first quadrant, my cosine is my x-coordinate, which would now be positive. So I just filled in the notes without the screen messing up. So in the first quadrant, if the cosine is positive, I take my x value of positive square root of 5. So the cosine would be positive root 5 over 3. In the second quadrant, because the cosine is negative, that's where I use my x value of negative root 5, and I put it back over my radius, and I know my radius is 3 from my original piece of given information. All right, please text me, send a message with any other questions that you might have.